Okay, welcome back to Moose and Chemistry. This is Reaction Stoichiometry, Limit and Excess Reactants, Lesson 2. In this case, we're given a balanced equation, and we're asked a simple question. What is the mass of aluminum oxide produced from 10 grams of aluminum and 10 grams of O2? Well, to do that, we kind of got to determine who's our limiting reactant, because our excessive reactant is going to produce more than we need. So the limiting reactant actually produces the least amount. And what's left over, of course, is the reactant that we call the excessive reactant. All right, so let's go ahead and set this up. And we could do mole ratios to figure out who the limiting excessive reactant is. But we could also just take these two masses here, this mass and this mass, and we can determine the limiting excessive reactant that way also. Okay, so what we're going to do is we're going to take 10 grams of aluminum times 1 mole of aluminum divided by the molar mass, which we have right here, which is 27.0 grams of aluminum. Okay, we're going to times it by the molar ratio. There are 2 moles of aluminum oxide to every 4 moles of aluminum. See? 2 to 4. Pretty cool, huh? All right. So what that's going to give us is another step in our calculation. So we want to figure out what is the mass. We're looking for the mass. We're just looking for the moles. We'd stop there, but we're looking for the mass. So that's going to be in grams. So we're going to times this one more step. And 1 mole of Al2O3 we determined to be, of course, 102.0 grams. So we go 102.0 grams of Al2O3. Well, that's really cool. So aluminum cancels aluminum, moles cancel moles, moles cancel moles. So we get this grams. So let me go ahead and put this into my calculator. And I'll get right back with you. So I got 10 divided by 27 equals times 2 equals divided by 4 equals times 102.0. And that gives me 18.88 grams of aluminum oxide. So this particular amount, using the aluminum as the reactant, produced 18.88 grams of Al2O3. Okay, so let's look at the other reactant. We're going to start that off, and we also have 10 grams of it. So we take 10 grams of O2 times 1 mole of O2 divided by 32 grams, oops, I meant to write 2 there, 32 grams of O2. Wait a minute, isn't oxygen 16 grams? That's correct, but oxygen is diatomic. It has 2. As you can see what I just underlined. So we'll take that line away. And now we're going to turn this now into our mole ratios. So there are 3 moles of oxygen to every 2 moles of aluminum oxide. Okay, now we don't want the moles of aluminum oxide. We want to find out how many grams are being made here, by the limiting reactant. So we're going to take them, and we're going to moles of aluminum oxide, which we're going to take over 102.0 grams of Al2O3. So again, we go through and we cancel everything that's in common. So again, I'm going to take my calculator here, and I'm going to calculate this real quickly. All right, let's see here. So we're going to go 10 divided by 32 equals times 2 equals divided by 3 equals times 102.0. And that's going to give me 21.25 grams. So now, the question is, which one is the limited reactant? The limited reactant is the one that makes the smallest amount of aluminum oxide. Well, again, we have two reactants, aluminum and oxygen. So one of these guys are the limiting reactant. Well, let's look at our data. 10 grams of aluminum made 18.88 grams. 10 grams of oxygen made 21.25 grams of aluminum oxide. So this one is a lot less. That makes our limited reactant is going to be aluminum, and our excessive reactant is going to be, of course, oxygen. And you guys have an awesome day, and we look forward to seeing you again here on Moose and Chemistry.